we as human beings are just too impatient because the time from building a proof of concept until getting it into production and really have it as like the standard for everything, it takes a while.
And you need just a classic engineer who is good at piping data from one point to another, plumbing. And that's what's missing in most machine learning teams.
And the majority of work does not go into the code itself, but everything around. Welcome to the Innovation Engineer podcast, your favorite place for picking brains of your favorite engineers. So grab your nerdiest mug, fill it with your beverage of choice, and enjoy. My name is Tarek.
And my name is Waschi.
And today we talk about another one of my favorite topics, which is artificial intelligence.
Actually, I would say we talk about if machine learning is already dead again, because, there's this 7-year hype cycle which repeats itself. And I would claim actually that nobody's talking about machine learning anymore. Or am I wrong?
I wouldn't say so, because the hype might be gone, but this is actually a good thing, because hype is usually like over-promising stuff, and now we are in the phase of actually doing things with artificial intelligence or machine learning. And I think we are now at the point where AI is not really considered innovation anymore because it's a standard technology. So I don't think that people stop talking about it. It's just part of our everyday life now.
Yeah, but I mean, you are talking for machine learning or AI, whatever maybe is the difference. Maybe we're talking about it later. For how long now? Because I know that after you graduated, you already worked and did stuff with machine learning. This was 20 years before anybody else was talking about it, right?
Yeah, I mean, AI is basically something that was invented in the 60s. It's quite old. At least the ideas or the mathematical basics of AI. I studied 20 years ago in this field. It was basically my motivation came when I saw the movie The Matrix. This one was in '99, very, very long ago, a very long time ago. And what I really loved about this concept was that this movie showed things like swarm intelligence of these squiddy things that were flying around. We have this cognitive intelligence, this mastermind, but also this depiction of the agents, which is like the agent-based artificial intelligence. And this was the field where I started studying computer science in the lab for distributed artificial intelligence or agent-based systems. And this one was really, really interesting. And we did not really dive into the topic of machine learning necessarily. This was only one of the aspects of AI. And I really, really loved this, and it was always a very promising field. But back then, of course, not the standard technology. And only with the rise of deep learning, it became so powerful that today we can't see any system anymore where it's not one component based on AI. And so I think, people stop talking about this because it's simply a standard right now.
I would say deep learning, wasn't it already 40 years old? I mean, all this deep learning stuff, it's not new. It's just like scaling and computational power is now good enough that you actually can use this in production, right?
No, I think deep learning is actually quite new. Let me quickly Google that.
Okay.
I think deep learning is something that was, let me check. We can be so spontaneous. Deep learning is only a couple of years old. Okay, so there were actually papers about deep learning, obviously, in 1971. Okay, so the concept is not really that new.
That's what I meant, actually, that's a concept and all the science behind it. It's really, really old already. It's just that it was not feasible with the computational power you had back in those days. So it's, again, the same with all these new language models we have right now, where they improve year by factors because the network gets more complex and it just scales with pure mass, actually, and that makes them more natural. And I think this is also thanks to our graphic cards being able to do a massive parallel computation. And I think quantum computing would be the next driver for machine learning. But I think we should talk about quantum computing in another episode, actually.
Yeah, that's true. And while I'm skimming right now the Wikipedia article for deep learning, I think the event that I meant was in 2012, where in a hackathon, people were for the first time applying something like a deep learning algorithm to do some kind of classification. And for the first time, it was actually working better than everything else. And I think this was like the beginning where deep learning became the new standard for all kinds of machine learning algorithms.
I knew it. A hackathon was a breakthrough moment. It's like with everything like which is innovation right now, it mostly comes from a hackathon. Oh, where does Netflix or the Dropbox get its innovation from? Yeah, from hackathon to hack weeks. Right?
Right.
Yeah. But I would still claim that there was this hype phase, like which was I don't know, up until like last year maybe, because this year everybody is talking again about the next things. But like 3 years ago, you wouldn't get a funding if you hadn't written machine learning. Okay, sorry, you'd write artificial intelligence on your PowerPoint slide, and if you do it like as a real engineer, then it's machine learning. So if you didn't write AI on your PowerPoint slides, you didn't get a funding because then it's scaling because it's AI. So like we want scaling business models.
Yeah, I mean. On the one hand, you're right. It is still kind of a hype topic when depending on what you're promising. And in the age of self-driving cars, for example, we are expecting a lot of artificial intelligence and that AI is basically solving everything and is doing everything perfectly. And this is a problem of overpromising and then under-delivering, because we see right now there are barely self-driving cars on the streets. Of course, there are so many pilot projects and experiments, but we are not really there yet. There is this last percent, this last step where we can't get it as reliable as necessary to actually roll it out as a self-sustaining, self-controlling system. We are very good in building prediction machines, and we are living right now in the age of prediction machines, and everything is built based on top of prediction machines. But it's only that. It's only like predictions, and we are not there yet that we actually can say our systems are reliable decision machines, making decisions as good as human beings based on context, based on semantics. This one will come, I'm very sure of it, maybe like in 10 years or 5 years from now, that we can actually reliably build these decision machines. But right now we are mastering the prediction machines. And so what managers are promising or politicians are promising and what then is actually delivered, there might still be a gap. And I think that's where these hypes are dying, because people see the reality is not as far as we think. But at the same time, the tools that we are already using, they are sometimes even superseding our expectations for this particular task that they are built on. Yeah.
It's like you said, it will come back, maybe not in 10 years, maybe in 7, because that's a hype cycle. But we were promised like fake voices, like deep fake videos, and everyone was afraid. And we are so far ahead. We will fake like Obama speeches, Trump speeches, and so on. This was like, again, marketing promises, right? And that's when the hype died, because I think in the next 7 years, there will be none good deep faked video of any politician. So yes, everybody was afraid of it, but we are not that far already in the game. So the same is with like faking voices. So I saw some big voice generation projects, and it still is not good enough to replace any voice actor. There's even like a startup out there I recently saw on LinkedIn, which is trying to create like marketing videos where you can choose between over 20 virtual actors which read out your stuff. You can select the outfit and so on, but it looks like computer generated graphics. So it's not as good as a real actor. And I think in the next years that will not happen. And I think that's the issue.
Yeah, I think we are basically, we as human beings are just too impatient, because the time from building a proof of concept until getting it into production and really have it as like the standard for everything, it takes a while. And so I think we see all these amazing prototypes which are already working, but they are not implemented yet. For example, I read an article about AI-powered traffic control systems, where the traffic lights of a city block in a simulation were controlled by an AI based on the traffic, based on accidents, based on the speed of drivers, based on the weather. And so this AI was able to manipulate the traffic in a way that there were no traffic jams and the cars were all very efficiently moving through the city. And this is an amazing application of AI technology. But even though this experiment was successful, it will take a lot of time until our infrastructure and our understanding and our acceptance of this kind of AI in our everyday society will take on and be applied. Even though I have no doubt that at some point of time we will be there, and it does not make sense to have these systems not controlled by an AI, because this is the only thing that makes sense. Everything has variables, and of course our systems need to be smart enough to react to all these variables. But it will take time. And so when we take a look at NVIDIA and their graphic cards and what they are capable of today, in all their demonstrations, we see this is so amazing, but we don't see this applied yet because the software did not catch up yet. And so with all the deepfake, I am very sure that in the next years it will become more and more the standard way of using video. And for example, Snapchat, these Snapchat filters, they are amazing toys. It's just I morph my head into a cat head, like a comic cat head, and it works perfectly. It is so amazing. And now imagine, like 5 years from now, I will be able to morph my head into a real-life Barack Obama, right? Because real-time rendering will be so precise and deepfakes will be so easy to produce that this will be no problem at all.
Yes, in the future, you're right. But my claim was that right now, the hype is gone and it's nearly dead again, the topic. So data science is staying. So I have a theory that you have a new field in computer science, like also every 5 to 7 years. So first it was like front-end engineers. You know, like 20 years ago, everything was kind of back-end engineering and you did like hardcore programming. And then the web came and those front-end engineers who were often self-taught, only knew HTML, CSS, and then a little bit JavaScript. And, oh, I only know JavaScript. Let's invent Node because I don't know anything else. And they reinvented like things like, oh, I now can test my software. Really, I did this for 40 years. So, you know, and it was the same with app developers. Then like apps became a thing and those app developers. And each time I was at a conference for app developers or saw a talk from any app developer, I was, okay, you're telling me stuff I knew for 10 years and you are like marketing as new stuff. Oh, we discovered something new in software engineering, a new pattern. Yes, this pattern was described in a book 30 years ago. I'm sorry. And the same stuff happened again with data science, so which now became machine learning engineers, right? So they were often self-taught, learned some Python, tried to solve everything with Python. That's why Python is currently hyped, and a lot of startups like Clubhouse used Python because it's widely used in data science. And what happened with all the other fields is that they matured. They become more mature, actually, right? And I think the same will happen with machine learning. So I would say it's currently not. There is research going on, but it's already commodity, right? So I would say this prediction models, everything is commodity, and you should stop. If you're trying to build something yourself, you should stop, use just the existing service.
Yeah, I mean, this rule can be applied to everything, right? I mean, sometimes if you have very, very specific requirements, then of course you have to think about building things up from scratch. But usually if you have a framework, if you have a pre-trained model, if you have something like a tool that is already doing exactly what you're needing, then of course it's common sense to jump in there. But this is always the smart decision making of understanding exactly your requirements and the constraints that you're dealing with. But this is, as you said, it's not a unique challenge for the field of machine learning. This is like everywhere. You need a content management system. Sure, you can reinvent one and build one from scratch, but maybe there's already a product that you can use like tomorrow simply by buying a license, which might solve all of your problems. Yeah.
Yes, but the thing is, if you wanted to use like a headless CMS, for example, like 10 years ago, you needed to build it yourself. And some companies did it were successful. And the same was true with like prediction models, like what Netflix did for like 10 years now. Like predicting what you want to watch. There was nothing in this field you could just use. Netflix invented a lot of stuff, did a lot of talks. I watched nearly all the Netflix talks about how their stuff works. They're quite old. And I did the project for a streaming service, which is TV Now in Germany, which is now called RTL Plus. So it's a German equivalent to Netflix, like the biggest streaming service. They have 2 million premium subscribers, which is kind of big for a national streaming service. And they also started building their own prediction models, like cosinus similarity. Then they had created word embeddings from all the descriptions and categories and stuff, and then document embeddings. And then they did a similarity search. They did everything themselves, even like widgets and also on. And then we had a bigger project for, it belongs to the Bertelsmann Group, which is Europe's biggest media company. And it was like, okay, we have radio stations, we have multiple TV stations, we have news stations. We own the worldwide biggest book publisher. We have so many magazines published Europe-wide. So maybe we should think not in like different entities, but as a whole, and create a new digital product for the digital area where all the content is in there. And we need also, obviously, a prediction model which could say, okay, you would be interested in also this page, like cross or upselling of different brands and so on. And then they came on board, the team which built this prediction stuff. They showed us everything. And it was really hardcore Python coding, really hard to get a production because it needed a CPU instruction set, AVX2, which was only running on Xenon processors. If you wanted to run it in the cloud, you needed specific instances of machines to run it and so on. You needed to update it. And then we said, okay, maybe we have some Elasticsearch experts. Elasticsearch can do similarity stuff. So maybe we import all your catalog data we have from all the different brands and stuff in a unified model, just in Elasticsearch, and use the similarity search from Elasticsearch. And guess what? It worked better than the 2 years work of like a whole team of machine learning engineers they invested. So my point is that there is AWS Personalize, there is Elasticsearch, which is already better than most engineers can build, like for prediction, for similarity stuff and so on. Use the existing tools. Don't try to build something custom. There is a cloud solution for nearly everything out there.
Yeah, but still it depends. And for this particular example and the short-term success, you might be right. I can't really predict like the future of this project, but it could be that in the long run, the long tail of this project, it might happen that a machine learning implementation would be more flexible or would be able to adapt changes in the data faster. I don't know, it might be. And so I think the biggest success of AI-based systems is that they are capable of adjusting very easily over time by retraining models over new updated data sets. And I think this is the charm of this. It doesn't matter. It doesn't mean that automatically every project is more successful in the first day. But the trend moves along that everything is based on AI systems.
Yeah, and at this point, I heavily disagree because I think the value is not in your machine learning model, not in the stuff you're building on your laptop. The generated value and the hard topic to tackle is MLOps, machine learning ops, getting your model into production. So in 2018, we got I worked at Axel Springer, where I still work, and we had the brand, which is Idealo, which is a price comparison website, and we got their head of machine learning to our subsidiary, and created Axel Springer AI. And one project they did for Idealo was like image classification for hotel images. And the hard thing was not building the model. That was done like in 3 months by 2 engineers. The hard thing was getting this running in production because each classification of an image took like 500 milliseconds. So it was like, okay, to get one run through all the images, it would take, with even a lot of computation power, because there are like 500 million hotel images, it would take months, multiple months. And then how do we update the model? What is when something breaks and so on? And the same happened 2 years later at Bertelsmann. I learned that what they built for TV Now back then was quite simple. I could run it on my laptop. Getting this in our cloud infrastructure integrated into everything, updated nightly and so on, that's where the magic happens. And the same is true with my last project, which is now Bitly Europe, where we not did machine learning, but a lot of data science. And the hard topic was not their Python scripts for predicting something. The hard topic was, how do we run this in production? And that's the value I see. So it's not really important if you have build your model yourself, you use AWS Personalize, you use Elasticsearch. It's how you integrate it, how you get it running in your production system.
Yeah, and MLOps is one of the new hypes that are emerging right now, because exactly what you said is totally true. This is one of the biggest challenges of actually getting these systems running. And so there are so many companies that are providing machine learning operations as a service. And this is now the next big thing. And I think on TechCrunch, you see so many investments in these kinds of companies, and they are like booming everywhere, and they will be like over time they will be swallowed by all the other companies, because everyone needs MLOps. Everyone who actually wants to run AI-based systems needs MLOps, and this is quite a challenge. And so this one is really another hype topic, which is not that how do you say it? It does not sound so great in the ear of the hype people, because MLOps sounds boring. But this is the field where everybody is bleeding right now, because it's really hard to maintain. And oftentimes you buy like a contractor, or you hire a contractor to build something like a machine learning based system, and then they build this up in a year, and then they leave, and then you're happy for a while. But what happens if you need like another data set, or something needs to be adjusted, right? Or the topic of operations, and then you start hiring from scratch, and then you are very, very frustrated because it did not run as you expected. This is like a long-term project. But still, I don't think that this is going to go away. I think that this will stay as the new de facto standard, even though it is true you can't say that machine learning is the best answer for every single problem. Yeah, but it is still a very, very powerful tool for many topics that we are touching.
Yeah, I call those people working on this ops stuff plumbers. That's really classical engineering. You need something to do data plumbing, actually. So this is where the missing part of a new emerging field in computer science struggles, like always struggles, with like operations, because that's the stuff where you need experience, where everything is the same for years, kind of. And you need just a classic engineer who is good at piping data from one point to another, plumbing. And that's what's missing in most machine learning teams. And if I would break down what is machine learning ops, it's like plumbing data. And that's what most teams miss.
Yeah, but as always, usually you build up something like a department for that, or you outsource this, use it as a cloud service. So this is, again, not really a new topic. Of course, you have to calculate for that. And the development of a machine learning based system does not end with the machine learning analysts or the data engineers. This is just like the creation of the magic itself, but not running the system. Yeah, and this, I believe it's the same problem that you have when you build a classical system, a classical software engineering system. You have the Java engineer, and he builds great Java applications, but if he never deployed this to production, then it is hard to actually get a system running that serves millions of users. This will not work. This will not scale. And there you need an operations engineer or an operations team or some infrastructure that can handle this. And the same thing happens with AI-based systems.
This is a problem I had with a lot of machine learning or AI teams, and the engineers working there. They think of themselves as researchers. They want to do like kind of this Google research, but build some prototypes and models. And like the companies I work for, they build products and they want problems solved. They're asking, okay, can I like save? I have 150 people working in my content department. How many people, or how good can I scale with your new solution? And they're like, I don't know. It's predicting stuff. So the problem is that they are or think of themselves as researchers and not as product builders. A similar problem to like engineers, right?
Yeah, of course, always. When I was a junior engineer, I really had no idea what this means. I came from university. I knew how software worked in theory. I knew algorithms and data structures and everything. And I came into this project and there were so many people, but not really many developers, and I did not really understand what all of these people were doing. Yeah, and then at some point of time, people were talking about CDNs, right, and deployment pipelines, and geo redundancies, and caching, and I never heard any of those. And I was thinking like, wait, but this is software; it's already doing what you want, right? And then I learned, no, this is like this small portion of this whole project, and the majority of work does not go into the code itself, but everything around it, starting from requirements engineering and deployment pipelines and code management. I mean, even managing like branches and stuff. This is something that you have to take care of, right? From development problems to deployment problems to testing to redundancy, backups. We didn't even talk about backups. All of these things, and so you can like have so many teams working on a thing and maybe have like 2 developers who are writing the code.
Yeah. Welcome to the wonderful world of machine learning, MLOps, right? That's what it's about. Right. It just you switch machine learning or like software engineering to machine learning. You need maybe 2 machine learning experts and a lot of other people doing all the stuff around it.
Yeah.
But maybe let's talk about projects you and we touched actually. So my favorite machine learning project or like AI project, what would you guess was it?
I guess it was the coffee maker mood bot.
Yes, that's totally correct. I loved it. So for the people who haven't seen our short YouTube video, sorry, it's in German maybe. Oh no, we have English subtitles. That's great. So you can watch it with English subtitles. It's built on OpenCV, Open Computer Vision, and it detects faces. It's running on a RaspberryPI, detecting a face, and if it sees a face, taking a snapshot and detecting if you are smiling. And if you are not smiling, it's telling a joke. And it was hanging above, it had a nice face, it was hanging above our coffee maker, an espresso machine, really great one, Rocket. And each time I came into the office, I came with the subway. I was grumpy. It was early in the morning. I didn't have my first coffee, which is always an issue. And then this stupid machine just told a joke. I laughed and hated it at the same time. And I also think this is, again, a great example of machine learning. A machine detecting a face and learning if you're smiling or if you're not smiling.
Right. It was, from my point of view, it was an amazing prototype. And from implementation standpoint, it is actually quite cheap. It simply had 2 components. The one was the component analyzing the image and understanding if there is a face or not. Really just a Boolean mechanism, there is a face on this picture. And the second one was analyzing the face and extracting or predicting a mood on this face based on like markers, if you're smiling or if you're not smiling, and calculating. It was calculating the probability of your face showing a positive or negative emotion. So it was not even like facial recognition, understanding who you are, right? This is not what the system was doing. It was way easier. And so if we cross this threshold of a certain probability that this person is not really happy, the system was reacting and accessing a database of Chuck Norris jokes, or I think anti-jokes or something, and was simply telling a very bad joke with a computer-generated voice, which is another aspect of AI, right? And so it was kind of creepy, but still very, very entertaining. And I think this mix of creepiness and entertainment was the genius part of the system. And of course, people were hating it, because they did not really understand what was happening there. And I think this is, if we take like the sociological aspect of AI machines, one of the biggest problems. Nobody knew what was happening. And at the end, we had to take it down, because even with the workers' union, it was like critical. Yeah, there's a machine taking pictures without like the explicit consent, and of course these pictures were not really taken and stored or anything. It was really just this real-time analysis, but still there was a camera attached to it and nobody was actually understanding. And in terms of AI ethics, yeah, this is like a critical thing. Everyone who comes in contact with AI needs, of course, to understand what is happening there. Otherwise, it's like a violation of your rights. Yeah. But from the engineering and scientific point of view, it was really an amazing example of what you can do with very easy to use open source components and like a cheap, I don't know, like €3 camera attached to a Raspberry Pi, which is also like what $30 or so in worth. So really cheap hardware, open source, free available tools, using these amazing things that sound like science fiction. If you would have told this to a person like 20 years ago, that basically everyone can use this today.
Yeah, and it's commodity. And the question is, if you take like nowadays, 2022, like 10 engineers and maybe 10 product people and show this product and ask them, is this AI? I'm not sure what they would say. And the other point is like, I was at a lot of hackathons and a lot of people were building stuff with prediction and image classification and so on. That happened a lot at hackathons. And they used hard models, training models. It took them very long. So one team just used like half of the hackathon, which was a 2-day hackathon, only to label data, so like fruits and vegetables, so that they could train their model. And with the stuff used for the coffee maker moodbot, that's like pre-existing stuff. So even the classification of if you're happy or not, there were models out there. So it was very, very easy to use and still very cool. So
yeah, that's true. Yeah.
Brings me back to our original point. What is the state of artificial intelligence? So I would say it's part of a lot of products, like with prediction, and even a lot of SaaS companies. They're using personalization, and you could be interested in whatever, right? So we even use it with a simple SaaS tool where you have a product, and we write like 5 content articles per week. And then in the product itself, if you add a special feature, we say, okay, you could be also interested in this and this. And also we see your behavior, what parts did you use, and say, okay, maybe you want to read about restaurants because there are different kind of verticals, how you could use our software in restaurants. It's running on very cheap stuff, on Elasticsearch with some similarity stuff and prediction and so on. And I would say, we would never market this as machine learning. So, right, because this is a very simple SaaS product, and we would never market this, oh, we are using machine learning to see what you're using, because it's already commodity. And like 3 years, 4 years, 5 years ago, in the startup incubators, where I also was as a mentor, like half of the companies did something with machine learning. It was such a big hype. So if you didn't do something with machine learning, okay, that will be hard. But this is gone. So I would really say the hype is gone. There are some companies trying to make money with products where you use like deep fakes of stuff, creating voices. But I still think that they are far away from what we would expect if you see the metrics and how an agent works and could fake like a human face and voice and so on in a perfect way. That will take 7 years, I would say. That will take another 7 years. And the other point is this big language models, which auto-generate text. They're awesome. So there were companies trying to create blog articles, like copywriting, with machine learning models. And they're getting better each half year, I would say, though. Every 6 months, I read a new blog article about, yeah, it's so good, it's so great. So everything what was awesome, like 2021, where I say, okay, wow, I just enter a sentence and it writes a full text about something. And if I just change some stuff, I could maybe even use it for my blog, if I just want some content for SEO and so on. And now, like half a year later, it's like, oh, wow, you cannot distinguish if it's a human or if it's like a bot. So I think this text generation, this will be the next thing, like this year, next year, where we see a lot of like new products being released. Still thinking that auto-generated voices and deep fakes is not going to happen. We were promised this like 3 years ago. I never saw it happen, and I don't believe in it for the next years.
Yeah, but still, it's just a question of time. I'm very sure it's a question of time. And when I was at university, one of our teams that I worked with, they were building smart home appliances. This was in 2003, and back then was we were showing this at CeBIT, like the big fair where like new technology was presented, and it was the same thing. People were saying, yeah, this is like a prototype, but it will take so long until we see it, and it's true. It took a long time since 2003 until smart home appliances actually became a thing. But it was happening. And so I'm pretty sure with all the deep fakes that at some point of time, maybe in 3 years, 5 years, 7 years, 10 years, this will simply be a thing where then the lawmakers, the legislators will start, I don't know, making it illegal to use deepfake technology or something because of the threat against society. Yeah, but I'm so sure as we see these Snapchat filters, this will become a thing that you create a filter of, I don't know, your girlfriend, and then you become your girlfriend in the chat room, and it will be really lifelike. Yeah, these things.
What do you predict will be like hype this year in machine learning or next big thing?
I have no idea. I don't know. There are so many experiments. I just read an article about a mixture of AI and metaverse, and it was about a system, I forgot the name, where while you were using your avatar in this metaverse environment, in this VR environment, your avatar is learning your speech pattern and the topics you're talking about while you're moving in there, and even your body movements, because it is like capturing you with a lighthouse camera, and so your avatar is moving like you. And this means that this avatar is actually starting to understand you and starting to imitate you. So if you're offline, your avatar can basically continue having the same conversations as you do, using the same speech patterns, using your same voice and your movements. And the idea was that it was the like a God mode. Yeah. So if in the real world you die, and you have bought a metaverse real estate there, people can go there and visit you after you have died, and you will be you with your voice and your knowledge and your speech patterns. Yeah, and there already, I think Microsoft had a patent in 2021 where they did this patent on dead bots. I'm not sure if they used this word, having a chatbot learning all of your email conversations and social media messages, and so you can talk to this chatbot. And you can't, it's like a Turing test, you can't distinguish between, am I talking to Waschi right now, or am I talking to the Waschi bot, which is trained on all of your social media data? And this one does not have an avatar. This is simply like the Turing communication test. But here we see another example of what is technically already possible and in like a prototypical state. And now with the emergence of the metaverse and meta creatures that you will meet there, being like AI generated or real human beings, I think this will be another thing that we will see now more and more often in the next years, where the metaverse will start getting into this hype phase and everything will be created for the metaverse, being, even though it might not make sense, or it makes sense, yeah, but everything will be created. And so maybe it's AI-based metaverse tools.
Yeah, it's. I think it was like in Superman, where he went to his ship, he came, and then his father was, I'm an avatar of your father, and he could talk to him, but still it was just a simulation. It was not the real deal. So, but
exactly,
there will be a point when you ask yourself, what makes a person, right?
Yeah, of course. And I mean, this is a perfect question. If I have an avatar and it looks like me, it speaks like me, and it even has the same knowledge as I have because it was trained long enough on everything that I was doing and saying, then we start talking again about this concept of a soul, yeah, something that makes me, which is living somewhere in me, but nobody can touch it or describe it. It's just there. And if I have a perfect copy of myself, then the only thing where you can point your finger to and saying this is not a human being or this is not a real person is, does it have a soul or not? Yeah, and now we are starting getting very, very philosophical, because if you can't distinguish between the original and the copy, then is there even a point of trying to distinguish it? Yeah, and that becomes now very, very philosophical.
Yeah, but this is a very big if. So, for example, Ghost in the Shell, this very famous anime,
right.
It has a different answer. The answer is, for like most of the human history, you have a ghost in yourself, like your soul, and you can't copy it. So you can replace nearly everything in your body except for the kind of a ghost, like your brain, because there's something in there, part of it, which you cannot replicate. And there, in Ghost in the Shell, there is no real artificial intelligence because it's not possible to do it. And the thing in the first movie is actually somehow one creature emerged, like an artificial being, one. So that's actually the story of the movie, that it was for multiple years not possible. You could like replace any part of your body, but you still needed your ghost, your being. And the main protagonist is like completely an android where everything is mechanical, except obviously for her ghost. Her whole body is even completely destroyed, and she gets a new body, or he, she, whatever. It's not important anymore. Gets a completely new body. And it was never possible to create AI. This is another option, right? This is also like a religious topic again, which we could touch at some point together with ethics in AI. Is a human going to be a god and create a new living creature, like something completely new? Or is it actually possible because we're humans and we cannot create AI? This is like a thing which is not feasible for us, which is a great question, in my opinion.
Absolutely, and especially when we take a look from the scientific point of view. And from the scientific point of view, it is really, really hard to point to this thing like a ghost or a soul, because scientifically you can't really prove it and you can't really touch it, and therefore you can't replicate it. Yeah? And if something like your mental presence is what we are calling a soul, then we might even be able to replicate and simulate it. Yeah, if we can make like a scientific list and a scientific description of what a soul is, like compassion and presence and I don't know, then if we can pinpoint it, then we probably can simulate it. And if it is possible to simulate it, then we might argue that it is actually there and we can create a ghost in a shell. But as you said, it's kind of spiritual, religious, and we leave the realm of scientific conversation or the scientific means of doing these things. But interestingly, we start having to have this real conversation. It's not really philosophical anymore if we start interacting with beings like that, and it's not science fiction anymore. Like I remember I saw Ghost in the Shell back in the 90s, and I loved it so much. It was so inspiring, but it was pure science fiction. And now we start talking about these topics not in the sense of science fiction anymore, but actually having to deal with virtual beings which might be considered alive. It's so crazy.
Fun fact, Ghost in the Shell is inspiration for Matrix and for a lot of scenes, and it's like what the Wachowski siblings, you need to call them, like said, okay, this is like actually we took this anime and the best out of it and made a movie out of it. That's where the Matrix came from. A lot of these great ideas actually come from there. Obviously, there are differences because there is real AI in the Matrix and it goes in the shell, not really. And we totally need to talk about what actually is the metaverse, and we need to talk about ethics and AI. So that I really think one of our next, or like 2 hour next podcasts will be those topics.
Yes, absolutely. Yeah.
we touched the metaverse so often, like when we talked about VR, AR, I think even when we talked about cryptocurrencies and stuff, and now, so we should talk about it actually, because I think
absolutely
we are still not really in the hype phase for the metaverse. It's really like a nerd topic for hardcore nerds, and it will take another like 3 years until my niece or whoever actually will even know the word metaverse, right?
Yeah, it is true. I think Mark Zuckerberg tries to kickstart the hype around the metaverse, but all we have right now is these commercials, and it is promising a lot of things. And with a market power of Meta, I actually believe that it will kickstart at some point of time, and somehow some companies and some products are already touching this realm, but it is so fuzzy that nobody can really draw this line about this is now metaverse, this is not metaverse. And so I think everyone is still very, very careful with this topic, because nobody actually knows if they are already in there or not. Yeah. So it's again like some kind of philosophy, and it's too fuzzy to actually say if we are already there or not. Yeah. So let's talk about this.
Yeah, you already teased like the whole episode, yeah. So we can already right. use it as a summary, I guess.
Exactly.
So let's wrap it up, actually. So I think I learned that today that prediction models are totally commodity, and that's where we are right now, and that we are not patient enough as humans. So that's why the hype is already gone again, and it will take another some years until some new hype comes, right?
Exactly, yeah. But so, it's normal.
Yeah, totally. What are we going to talk about next week, Tarek?
Maybe you can sum it up, because we talked about this right before this episode. There was this option, this study in the UK where they started talking about introducing a 4-day work week. And this was already kind of reason for some interesting discussions. And so this one will be part of next week's podcast.
Yeah, because I call this woke bullshit, and I don't believe this is a good idea. And again, scientifically proven that this will not increase productivity, because you're just, okay, let's not spoil it. Let's talk about it next week. So you can look forward to a hot discussion next week. Until then, at the same time, at the same spot, see you again next week.
See you again next week. Bye.